So now let's have a look at how we can use the concept of polarity. Okay, how we can use the concept of polarity of a molecule. Okay, by looking at the structure or the shapes of the molecule. So how we can use this concept of polar bonds and to see whether a molecule is polar or not. So again, we look back at what this whole concept is about. So polarity of a bond determines the polarity of a molecule, and this polarity of a molecule is important untuk dictate the physical properties of a molecule. So dia akan tentukan boiling point, dia akan tentukan melting point. It will determine whether a substance can be dissolved from one to another. It can determine whether a substance is sticky or not. This kind of concept of physical properties is all dictated by intermolecular force. So in order for us to go into intermolecular force, we need to understand this concept first. Okay, so we need to look at the polarity of a molecule. So how do we determine a polarity of molecules? So we look at this page 39. So we have to draw the plausible Lewis structure first, and once we have drawn the plausible Lewis structure, what we do is we need to determine the molecular geometry based on Vesper theory. Once kita dah dapat Vesper theory ni, kita dah tahu dia punya molecule shape, so we know how the terminal atoms are arranged around the central atom, we can add the bond dipoles together in a molecule to determine its polarity. So kita akan tengok, kita akan tambah-tambah semua sama ataupun tidak. We don't have to use an actual value, we can just use an unknown and see whether the unknown cancel out each other or not. So this is how we determine the polarity of a molecule. So this is the first step, the second step, and then this is the third step. So let's have a look at the work example. So by using your knowledge of relative position of elements in the periodic table, draw dipole arrows to show the bond dipole in the following molecule. So kalau kita tengok BeCl2, okay, kalau kita lukis Lewis structure dia, kita akan dapat like this. This is the structure of BeCl2. And kalau kita buat dia punya Vesper theory, okay, Vesper, this is AB2, and because of that, BE, the structure is like this, 180 degrees, and because of that, dia punya arrow would be like that. Daripada BE pergi ke Cl, because Cl is group 17, so it is more electronegative than beryllium. So it goes like that. So delta negative, but tengah-tengah dia delta positive. And because this one is the same magnitude, sebab dua-dua adalah Cl kan, disebabkan oleh itu, the electron are being withdrawn in exactly the same magnitude to this Cl and this Cl, and because of that, mu resultant, okay, ataupun net mu, net dipole moment is equals to 0. So this is non-polar. Okay, tapi this one dia tak minta lah. Dalam soalan ni kita nak lukis sahaja dia punya arrow. But like I said, kita kena buat dia punya Vesper dulu. And when we do CO2, Vesper dia is AB2, and this is C double bond O, also 180 degrees. So this would be the arrow like that. Okay, and when we do PCl3 pula, okay, PCl3, we will get the structure like this, AB3E. So the structure is trigonal pyramid. Okay, so this would be the structure. Now this is the first 3D structure that we are looking at. So this one is linear, it's only 2D. This is also 2D, but this is now, because it has the lone pair at the central atom like this, it is AB3E. So the electron pair geometry is tetrahedral, but the molecular shape is trigonal pyramidal. Okay, so kita ada P like this, Cl, okay, Cl, like that. So this is the structure, so trigonal pyramid, and we know that the phosphorus and chlorine is more electronegative, so it will go like that. So we will have a triangle pyramid, semua mengalir ke bawah like this. Okay, so kita ada this one right here, this one right here, and that one right here. And because of this, the resultant ataupun the mu resultant ataupun kita guna net is not equals to 0. So this would be the punya arrow. Kalau tengok dekat sini, this work example, this is poorly done because saya tunjuk halfway je. Make sure you tambah yang kena ada adalah this one, the shape, and the arrow must be added on the molecular shape punya drawing, not the Lewis structure. Here is a Lewis structure. Okay, alright. Now the next one, the last question is CH2O. Okay, so CH2O is methanol. Okay, so if we draw the structure, Lewis structure looks like this. So this is AB3. So this is trigonal planar, and because of that, this angle is 120, 120, 120. We put the angle here. I forgot to put the angle here is less than 109.5 degrees. Okay, so here is 120, 120, 120. So between this is hydrogen and carbon. Carbon is more electronegative, delta positive, and this is delta negative. And because of that, kita ada arrow like this, and like that. So if we were to draw the vector diagram, it would be like this. Ni adalah daripada H yang sini, ni adalah daripada H ke carbon yang this one, and then kita ada oxygen like that. So dia punya resultant would be, this is the mu net there, and this is not equals to 0. Okay, but again, in this question dia tak minta net dipole, saya nak tunjuk sahaja. In this question dia sampai sini sahaja, only up until then. Okay, so this is another example that uses 3D structure. Okay, so kita ada 4 polar bond, carbon and hydrogen. It is arguable that carbon and hydrogen is polar bond or not, because carbon and hydrogen, the electronegativity is not that much different. They are actually quite close to each other. Carbon is 2.2 or something like that, and hydrogen is 2.1, if I recall correctly. So tak jauh beza, and because of that, dia punya electronegativity is very small, the difference between them. But the bond is still considered polar in this case lah. But kalau kita look at Lewis structure, we get this shape. But if we determine the molecular geometry, we get 109.5 like this. Okay, so to determine the overall dipole, we draw the structure in the form of its 3D shape. Okay, so like that. And because they all have the same angle, here, it's all 109.5. Because of that, mu net would be equals to 0. This would be polar sebab it will go to all different directions at the same magnitude, and because of that, the molecule is non-polar lah. Non-polar. Okay, alright, so that would be for polarity, bond polarity, and dipole moment, and how we determine whether a molecule is polar or not. So to recap back, what we need to do in order to determine whether a molecule is polar or not, we need to make sure that the molecule is drawn in Vesper shape lah. Guna Vesper theory, kita lukis molecular geometry, and from that, only that point onwards, we can conclude whether the summation, okay, the sum of all of the dipoles, individual dipoles, will result in net dipole that is not equals to 0 or not. And this is what determines whether a molecule is polar or not.